I want you to take a look at the following components. First, this cube, scaling over time automatically. Then we have this digital display, which updates in real time to show how far away the player is. Next, we have a fully animated lever with 4 different states. Over here, we've got a smoothly animated drawer that slides open and closed when I interact with it. And finally, this platform which moves up and down when I press E. Here's the cool part. All of these features were built using the exact same custom component that I will show you in this video. And even better, each one took less than 2 minutes to set up. Take the drawer for example. All the smooth motion you see is handled by this small bit of code. That's it, that's the entire code for the drawer. With the component I'm going to show you in this video, you'll be able to create any kind of tweened or animated 3D mesh movement in Unreal Engine, whether it's a drawer, a platform, a lever, or even a 3D dynamic UI display. At the end, I'll also show you how I created each one of the examples that I showed you right now, so you can see how powerful this tool really is and what you can do with it once you have it. Quick note, in the description there's a link to my Discord where you can download the project files for free and also ask if you have any questions related to this or any other Unreal Engine project. These videos are a ton of work to make, so make sure to drop a like and a subscribe so you don't miss out on any future content. Now, let's not waste any time, jump in and start building it. Alright, with your Unreal open, you are now ready to start creating the component. Now, before we actually start coding, I will show you how the drawer example from earlier is set up exactly in Engine, just so that you understand better what we're doing when we're actually writing the component itself. While it's not the prettiest, it gets the job done and lets me explain how this works. Big shout out to this YouTube video, which gave me the idea that you can actually inherit components in order to create your own custom behavior. And that's exactly what we will be doing for this custom component. Now, if you don't know what I mean, here, let me show you. If I go to add, I can add a cube to this actor. This cube is basically a static mesh component. Because Unreal Engine is an object-based game engine, we can actually inherit from that static mesh component. If I go to my content browser, I can right-click, blueprint class, I can search for static mesh component. If I click this and select it, I now have created my very own custom static mesh component. If I drag this into my actor and assign a mesh, you can see that my custom static mesh component works pretty much exactly like the default static mesh component. But there is one difference. I can actually open up this custom static mesh component and add logic to it. Let's say I want to add a red material every time the game starts. I can go into the static mesh component, into the event begin play, and I can call set material. I can assign my red material here, just like this. And now every time my actor is ran, you can see that the cube will automatically turn red. This is incredibly powerful because this allows us to essentially create template static mesh components with logic that we might use a lot. The component that we're going to build today is set up the exact same way. If I go into the drawer example right here, you can see that we have some extra values and variables at the side that you wouldn't have in a normal static mesh component. When we go down, we have translation. Here we have a mode, an axis, a maximum rotation scale and translation, and an interpolation speed. If you understand this, you understand the entire system. Our mode right now is set to move. This means that this drawer will be translated, so it will be moved. We also have a rotate and a scale mode. The axis will define on which axis this component will be moved, and the maximum value over here will basically define how far or how much the component will either be rotated, scaled, or moved. So in this case, the value here is 70. This means that this component will be moved a maximum of 70 units on the y-axis from its default location that we've just set in here in the editor. And what defines how much is moved? Our value that we have over here. If our current value is 0 and the maximum remap range is 1, then our component will stay where it is by default. If we move up this current value to 1 with our maximum remap range still being 1, then our component will be moved all the way to our maximum rotation, scale, and or translation of 70. In this case, it will be opened. While this might be a bit confusing, just stay till the end, because once you actually have the system and write your own doors, whatever, it gets a lot more understandable. Okay, let's see how the code works for the drawer. When we interact with it, we have a flip-flop. Now, we're going to update the values and set them either to 1 or to 0. And this will then set a custom value on our custom component. It's that value right here on each of the drawer pieces, either to 0 or to 1. 1 meaning open and 0 meaning closed. You may be wondering why this is so complex, because we could just be using a boolean here, right? Well, to explain that, I then have to show you the lever example, because this is where we are making full leverage of this powerful system. When we flick this lever, our value will be either 0, 1, 2, 3, or 4 set by our code. And then our lever will interpolate between the minimum remap range and the maximum remap range how much it should rotate, either from its default base rotation that it's on right now, to show you the code of the lever that you can understand it a bit further. Every time we interact, we're adding to a lever index. This lever index can be a maximum of 4. And then we are setting the current value of our custom component to that lever index, meaning we interact once, this value is going to be 0. We interact again, it's going to be 1, 2, 3, all the way up to 4, and then 0 again, just like you would expect. I hope you now understand how the system works. We're now going to move on to writing the actual system. First, open your content browser, and we are going to create a new blueprint class. Just as we said earlier, we are going to create a custom static mesh component. So we're going to search for static mesh component, select it, and we're going to call this custom translation component. If I now open this up, we can start writing our logic. But first, just for your understanding, I would like to add this custom translation component to our actor that we have here. So just add it, and you can see that I can add it just like any other static mesh. To clean it up a bit, and let's set this to be just a cube for now. There we go. That's great. All right. The first thing we are going to do is we're going to create a few helper macros. These are just some small helper macros for code later. So the first one we are going to create is called vector to rotator. As an input, it's going to take a vector, and we're just going to call this vec in vec, short for vector. If I right click, I can split the structure pin. As an output, we're going to output a rotator. We're going to call this out rotator. And we're also going to right click and split it. Now we're just going to simply connect each of these, and that's our first helper macro done. Let's create a new macro, and we're going to call this set vector on selected axis. All right, for this macro, we're going to need some more variables, and we're going to need an enum. Go back to your content browser, and I'm going to create under blueprints an enumeration. I'm going to call this e-axis, and going in here, we're just going to create 3 enumerators, an X, a Y, and a Z. Control S, and we'll go back into our component. We'll create a variable, and we're going to call this axis. As a dropdown, we're going to select our E-axis enumerator, just like that. Compile, and now we can select it here in the dropdown. We're going to click the little eye icon to make it visible, and I'm going to move this into a category. In this case, 02 translation, because it's something that has to do with the translation of the object. Now, coming back to our macro is going to take 2 inputs, a vector and a float, and we'll call the vector in vector, and then the float the modified axis value. This macro will allow us to change only one value on our vector, but only the one that we have currently selected on our axis enumerator. Basically meaning, if we have selected an axis of X, then we are going to set whatever value we're getting in here on this vector on X. If we have selected an axis of Y, we're going to change the Y value of this vector. If we've selected Z, then the Z. We're going to drag out of the vector, break it, and then we're going to drag in our axis from before. And we're going to drag out of that, and we're going to search for select. This will allow us to select. This node will essentially, depending on what this enum is set to, it will take whatever is fed into these options. Then we go to output, add an output, and the output of type vector, we're going to call this out vector. This will be our modified vector. Drag and drop from the select node into the out. And now it's going to get a bit confusing, but stay with me. We're going to right click the X. Now, if our axis is set to X, we'll only want to modify the X value of the vector. All the other ones we want to be left unchanged. So we'll drag the axis modified value from our input into the XX, the XY, and the XZ. We'll drag and drop the X and the Z value from our default vector because we don't want to change these. Now for our Y, we'll only want to modify the Y. So we'll drag and drop the modified axis value into the Y. And for the YX, we're gonna pick our default X because we don't want to modify that. And for the YZ, we're gonna pick the default Z. For the Z, we'll do the same. We'll split it, set the ZX to our default unmodified X, the ZY to our default Y, and the ZZ, we're going to set that to our modified axis value. This is our set vector on selected axis macro done. We'll create a new macro and call it rotator to vector. This will be very similar to our vector to rotator macro from earlier. As an input, we're going to get a rotator. As an output, we're going to get a vector. The in, we're just going to call rotator, and the out, we're just going to call vector. Right click both of them, split them, and we're just going to connect all the X to the X, the Y to the Y, and the Z. See, the next macro we're going to need is called a vector to selected axis macro. This macro will let us pass in a vector, and then we'll only get the axis that is relevant to us because it's selected in this axis enumerator. We'll drag and drop the axis enumerator in, and we'll get an input of type vector. We'll call it in vec, and the output will just be a float. We'll call this out float on axis. Let's break the int vector and drag out of the axis, select, and we'll connect the X to the X, the Y to the Y, and the Z to the Z. Drag out of this select, and this macro is done. If we pass in a vector, the system will check what axis we've selected in our axis enum, and then it will only give us the axis that is relevant to us. I will move all of these enums into a category called calculation. All right, this is it for the macros for now. We'll move on to our event graph. First, let's create the event begin play. Dragging out of there, we're going to get our relative rotation. We're going to convert that with our custom rotator to vector macro. We'll also get our relative location as well as our relative scale 3D. Now to continue, we're going to need one more enum. Open your content browser and we'll right click, go to blueprint, enumeration, and we'll create a new enum called e_mode. Open it up, and in here we'll create 3 enums: rotate, move, and scale. We can save it, go back to our component, and in here we'll create a new variable called this mode, and as a type we'll select our created custom mode enum. I'll add this to category over here and click the little I to expose it. Now we can also drag and drop this in here. We'll drag out of it and again call a select node. When we select the rotate mode, we'll pass in our rotation, the move, the location, and the scale, And I'll drag out of here and promote this to a variable, and we'll call this start relative scale / rotation / location. We'll need this to then later interpolate between the start and whatever we have set as a target location in our code. Now let's connect this, and we'll go down to the event tick. I'll create the event tick, and first we'll make the little enabled boolean that we had earlier. I'll create a new variable and call this enable. We'll set the type to boolean and drag out of here. Hit here. We'll again click the I to expose it, and for the variable that we made earlier, I'm actually going to set this to private, and I'll move it in its own calculation category over here, just so that we can't see this in the editor. Moving on with our enable, let's create a branch by holding B and left clicking, connecting it, and dragging the enabled in here. To continue, we're now going to create one more macro. We're going to call this macro current relative macro. Now this macro is going to return the current selected relative rotation, location, or scale, whatever is selected. We'll first get ourselves the relative rotation. We'll do the same for the relative location and the relative scale. All right, we'll use our rotator to vector macro, and then we'll drag and drop the mode. Drag out of it, select, and you guessed it, the rotation goes into rotate, the location goes into move, and scale goes into scale. Now we'll add two outputs. The first of type float, we'll call it on selected axis, and the second we'll just call it relative of type vector. Now what we did here, we'll just plug this into the relative, and then we'll drag out of here and call our vector to selected axis macro. Drag and drop it in here, and we are ready to compile. Now what this macro will do, it will return our current relative selected rotation, location, or scale, and it will also provide us with each of these values only on the relevant selected axis over here. We can do that because we have our own custom macro that we made earlier that will give us only the selected axis. Going back to the event tick, we can actually already drag and drop our customly made macro in here, and then we can use our already created set vector on selected axis macro. Then we can just connect the relative. Now we'll need one more macro, and this macro will be called calculated target on axis for mode. For this macro, we'll need yet another variable, and we'll call this target scale slash location slash rotation, and it will be type vector. Again, we'll check the little I, and we'll move it into the translation category up here. Now in this macro, we're going to basically interpolate, and you could say calculate the target rotation or scale that we have with the current value. We'll actually create a new variable here, and we'll call this interpolation speed. Just how quick we want to actually move, scale, rotate our object. The default interpolation speed, I'm just going to set that to 5, and I'll also move this into the translation category. All right, let's create yet another macro, and we're going to call this calculated target val. This will return only one float. We're going to call this target value, and in here we're going to need a map range samped, connect that to the output, and now we need to create a bunch of variables. First, we need a current value. We need a minimum remap range and a maximum remap range. We're going to expose all of these, and we're going to move these into their own collection. I'll call this 01 value, just like that. We're going to actually remap from our current value with an in range of minimum to maximum. We're going to remap to the start, scale, location, and rotation. We're going to use our vector to selected axes custom macro, and going to plug this into the out range A. And for the out range B, we're going to create a new variable, and we're going to call this maximum rotation scale translation. Click the little I again to expose it, and I'm also moving it into the translation category all the way up here, just like that. And we can connect it all the way into our outrange B. Now this is a bit confusing. If you don't understand it, that's totally okay. All we're doing here is we're calculating how much we want to basically rotate or move the object based on our current value that we have set here. This will basically convert the current value, say this is in a range from 0 to 1, to our range of, if it's a rotation, 40 degrees to 90 degrees. Oh, I did a little mistake here. We actually need to swap this to the start relative location. We can now return to our calculate target axis for mode, and I'm going to drag and drop my target's location, scale, rotation. I'm going to drag out of here, and we're going to use our vector to select an axis macro. I'm going to get the calculated target value that we just made. I'm going to get a get world delta seconds node, and I'm going to get our interp speed. We can now use the finterp2 node to basically interpolate smoothly to that value, just so that it doesn't snap. We can now drag and drop the target scale into the current, the calculated target value will drag it into the target, delta time into delta time, and the interpolate speed into the interpolate speed. Alright, to continue, we'll drag out of this, select float. We're going to create a new variable called smooth over time, and we're going to also check this little value so that it's default enabled. Now we'll drag it into the pick A. So by default, we want to have it be smooth. If it's not, then we'll just use our calculated target. value. Let's drag out of here and put it into the output, and we're done with this macro. If we now return to the event tick, we can get our calculate target on axis for mode, drag and drop it in here, drag out of this, and we'll promote this to a variable, call it target scale / location / station. Now I'm going to move this into the calculation category that we made earlier, and I'm going to also set it to private so that we can't modify it in the editor. Let's connect this into the true so that our graph looks like this, and I'm going to get our mode enum from earlier, just drag out of here, and we're going to switch that mode. If the mode is rotate, we're going to set the relative rotation. If it's move, we're going to set the relative location, and if it's scale, we're going to set the relative scale. Now you can get your target scale rotation location value here, drag and drop that in the lower two, and then we'll get our vector to rotator macro, and we'll just drag and drop this into the top one for the rotation. This is the entire component done and ready for use. You've made it, you've done all the annoying math stuff, and now we're ready to have fun with it. So let's just set the default values for all our variables. Axis by default is X, mode we can set it to rotate, the interp speed I'll just set it to 5, maximum remap rotation scale whatever, I'll just set this to let's say 30. For the value, a default of 0 is fine. Minimum remap range, I'll leave it at 0. Maximum, I'll set it to 1. And then enabled will check by default. Smooth, I'll also check. Now we can compile this and we can move on to our example. As an example, I'm just going to make a door. Let's create a blueprint class. I'm going to call this EP door, and we can open it up. First, we need an actual door. I'm going to add, but not a normal static mesh component. We're going to use our custom translation component that we just created. And as a static mesh, I'm just going to look for a cube. I'm going to just take a cube from the level prototyping here because it has the pivot all the way on the bottom. We'll size this so that it kind of resembles a door, just like that. And now it's time to actually set up this door. Now we want it to rotate when it's opened. We could also make a move, honestly. I'm just going to set it to move. On the axis, well, let's see, where we want it to slide open on the x-axis. So we'll set it to x. The speed of 5 is fine. And the maximum, well, we'll have to check. So by default, we're at just 0, 0, 0. We want it to move to the right all the way till it's at, let's say, 115. So I'll copy this value, put it all the way here into the maximum rotation and scale, just like that. We can now reset the door so that it's by default closed, and we can go down. The current value, I'll leave this at default so that it's just 0, minimum remap range also just 0, and the maximum I'll set it to 1. Now we can compile and we can write the actual logic for this door. Now I've already set up a very basic interaction system over here for my character. If you don't know how to do that, I've linked a great tutorial in the description that should work totally fine for you. Just pick one, whichever you like, with an interface. I'm going to go to my door, go into class settings, and I'm just going to add my interactable interface over here. And I'm going to go into the interact function, just like that. Now, you can of course trigger this any other way you'd like. For me, I'm just going to do it with an interact. I'm going to drag out this custom translation component, and every time we interact, I'm going to get a flip-flop here. We either want to set the current value to 1 or to 0. So let's just drag out, set it to 1, and then copy this, and we'll set it to 0, just like that. If I now compile, go into my level, drag and drop the door in, and we can play. If I now press E, you can see that this door slides open nicely. Now let's say I didn't want this door to actually move. Let's say I wanted it to rotate open. That's super easy to do. All I need to do is I just set this to rotate, and we want this to rotate on the Z axis, right? So I'll set the axis to Z. As a maximum rotation, we'll just give it 90, and now compile and go back into the level. If we now press E, you can see that our door nicely rotates for us. Pretty neat, right? Let's say instead of rotating on the Z, we would want to rotate on the X. So we'd have a nice kind of bridge door, just like that. Super easy to do, right? All right, one thing we could also do is we could make the door just kind of scale out. So if we set it to scale, we'll set the maximum rotation scale just to 0. and then we go back into the level. If I now interact with it, you can see that it just kind of disappears. Now I won't be able to interact with it to open it, so I'll just add a quick box collision so that I can still interact with the door. And I'll also add a nice door frame for my door. Pretty neat. The amazing thing about the system is if I now want the store to not just be one side and I want to have two doors, I can do that super easily. I can just get my mesh component here, move it all the way over here, and rotate it 180 degree. And we just need to do one more thing in our code, get our new mesh component here, and we'll set the values for that one as well. Just the same value that we're setting for the other one. Compile, go back, and now if we interact with it, you can see we have two sliding doors that will open for us just fine. Whoops, some quick adjustments, and there you go. Now it's a rotating door again. Pretty cool, right? You can see that this system is incredibly flexible and you can do a lot of stuff with it. I just want to show you one more thing, which is how you can actually do stuff that's dynamic, such as health variables for an example. Because right now we're just working with stuff that has two states, right? The store can either be open or closed, but we can actually do a lot there. So let's say I didn't want the store to be open immediately. Let's say I wanted it to be open depending how far my player is away from it. Now we can do that incredibly simply. Let's go back to the door, and instead of setting the value to 0 or 1 right away, we can actually do this in event tick. We'll get the event tick here, we'll get our player character with the get player character node, and we'll get the actor location. I'll remove the alt interaction code here, and I'll also get my actor location like this. Now if we get a distance, just like that, and we'll get our custom mesh components here and set the current value to that distance, just like that for the other one as well. We'll just have to do a bit more setup here. Let's select the translation components here. And now in here, we'll have to change the remap ranges. Now I'll just set the maximum remap range to, let's say, 600, and the minimum remap range, I'll set it to 80. The default value can still be 0. If I go play now, you can see that the closer I get to the doors, they will actually close. Pretty cool. If I wanted it to be the other way around, I could set the minimum remap range to 600 and the maximum remap range to 80. If I now come closer to this door, you can see that it's just opening for me so that I can pass through. Pretty cool. Alright, that has been it with this rather long tutorial. If you enjoyed it, please leave a like and subscribe to not miss out on any other future content. On the screen you'll find a video with 10 Unreal Engine plugins that will completely speed up your workflow. So please check it out, leave a like, subscribe, and I'll see you in the next one.